Hey guys, today we are going to be going over 5.2 triangle congruence, angle, side, angle, 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 side, and hypotenuse leg. Today you will use the definition of congruence to develop more shortcuts, angle, side, angle, 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 side, and hypotenuse leg for proving that two triangles are congruent. First, we are going to be looking at angle, side, angle, also known as ASA congruence. This postulate states that if two angles and the included side of one triangle are congruent to two angles and the included side of the other triangle, then the triangles are congruent. So an included side is the common side of the two consecutive angles in a polygon. Okay, when looking at the first example, we want to identify each pair of corresponding congruent parts for the given figure. So to prove the congruency, we can look at angle SWT, which is that angle, and we can look at angle UVT, which is this angle right here. And those are corresponding parts and are congruent. We can also see that WT and VT side lengths are congruent. And we know that WTS and VTU, the angle between these two, is congruent because of the vertical angles theorem. So we can write the congruence statement for the given figures. So triangle SWT is congruent to triangle UVT by side lengths of the given triangle and the two angles. So it's going to be angle, side, angle. And these prove that there's congruency. For example 2, we're going to use angle, side, angle to explain why triangle UVX is congruent with triangle WVX. So when we go to explain these, we want to figure out what information they have given us first. If you look here, they're giving us information about the angles and then also about the side lengths, because these two share a side length. First, you can see that UXV, that angle is congruent with WXV. So these angles are congruent, and that's one of the information that they have given to us. And since angle WVX right here is a right angle, then we also know that the angle right here to the left of it is also a right angle. So because these two are a linear pair, UVX, then we can conclude that angle WVX is congruent with angle UVX. We also know, because of the reflexive property, that this VX is congruent. Therefore, we can say that triangle UVX is congruent with triangle WVX by angle, side angle. To complete the statements about angle, side angle congruence, the first step would be to look at what has been given to us. So for the statement AD is parallel to BC, we're going to look, and that has been given to us. AD is parallel to BC. So that reason is given. Number 2 statement says that angle ADE is congruent to angle CBE. So it's talking about these two angles. We can use the alternate interior angle theorem to conclude this, that these two are congruent. The next statement says is DE is congruent to BE, which that information was given to us. And number 4 states AED is congruent to CEB, and we know this because of the vertical angle theorem. So these are what tells us that triangle AED is congruent to triangle CEB by angle, side angle. Next, we're going to be looking at angle-angle side congruency. If two angles and a non-included side of one triangle are congruent to the corresponding angles and non-included side of another triangle, then the triangles are congruent. So first, we're going to identify each pair of corresponding congruent parts for the given figures. So here we can see that G and angle K are congruent. So angle HGJ is congruent to angle LKM. We can also see from the figure that angle J is congruent with angle M. So angle GJH is congruent to angle KML. And then from the figure we can also see that HJ is congruent to LM. So based on angle, side, we can tell that these two triangles are congruent. So triangle HGJ is congruent to triangle LKM by angle, side. For the next example, we're going to use the angle, side to explain why triangle NKM is congruent to triangle LMK. So by looking at this figure, it is given that NM is parallel to KL. So because these are parallel, we know that angle M and angle K are congruent because of alternate interior angles theorem. It is also given that NK is parallel to ML. So because N and K are parallel with ML, we know that angle NKM and angle KML are congruent by the alternate interior angles theorem. So by angle, side, we know that the two triangles are congruent. So triangle NKM is congruent with triangle LMK by angle. Okay, for example 3, we have to find the reasons that each statement proves the two triangles to be congruent. Okay, with the first statement, the fact that JL bisects angle KLL is given. And then the angle KJL is congruent to angle MJL is not given. But we know because of the angle bisector theorem that these two are congruent. They did give us the information about the angle K and M being congruent. And we know that JL is congruent to JL because of the reflexive property. So we know that triangle JKL is congruent to triangle JML because of the angle, side congruency. The next congruency that we are going to be learning about is the hypotenuse leg congruency. The theorem states that if the hypotenuse and a leg of a right triangle are congruent to the hypotenuse and a leg of the other right triangle, then the triangles are congruent. So for example 1, we're going to identify each pair of corresponding and congruent parts for the given figures. As you can see in the figure, AC and PQ are congruent. We also know that AB and PR are congruent. And we also know that ABC and PRQ are right triangles. So we can write a congruent statement that triangle ABC is congruent to triangle PRQ by the hypotenuse leg congruence. For example 2, we're going to use the hypotenuse leg to explain why the triangles are congruent. So we're going to look at what is given to us, and what is given is that AC is congruent to DB. And we know that BC is congruent to CB by the reflexive property. And since these are right triangles, ABC and angle DCB are right angles. So these right angles that make up our triangle make the triangle a right triangle. Therefore, triangle ABC is congruent to triangle DCB by the hypotenuse leg theorem.